we are back onto the screen. So what we are looking at is what direction will be the force when a current carrying wire is placed in a magnetic field. So magnetic field is going to the right of the page, current is going in this direction. So let's figure out the direction. So if you imagine you're using your right hand, so place your fingers to the right of the page, the right of the screen, and then turn your right hand, so your thumb is pointing in the direction of the current. And if you now imagine you are moving your hand to give a slap, so your hand moves in an upward direction, doesn't it?
Yeah.
Okay, so that means direction of the force is up the page, over here in this direction. If the direction of the current is reverse, then the force will be in the opposite direction. So that's the basic rule. So whenever there's a current carrying wire placed in a magnetic field, it produces a force which will make this wire move, and that can be used to produce motion, or this is called the motor effect. Now, what is that force? We call it magnetic force because it is due to the magnetic field, and it is proportional to the magnetic field. So if magnetic field is increased, force will be larger, or if current is increased, force will be larger. And this is the length of the wire. So length is only the length which is inside the magnetic field. This wire could be longer, but it's only the length, because only the charges which are moving in this part of the wire, they will be experiencing a force when the lines of magnetic field are crossing them, and that's why they move, and it will be moving upwards. Now this force will be maximum if the current is moving at 90 degrees angle to the direction of the magnetic field. So magnetic field is in this direction, that's at 90 degrees angle, so at this position is maximum. However, if current carrying wire was placed in this direction parallel to the magnetic field, then it will not experience any force. And that's what the sine theta is. Generally, you would not have to worry about that one, because you will be given the questions which are like current will be going at 90 degrees angle. So that's the formula. We use right hand slap rule, which is given in the notes here. You might have read that in Friday's lesson, and that's what we discussed. I will just do, say, one of this. There were 2-3 examples. I will just do one. So say, for example, in this one, if you guys try, I will just let me hide the answer. So if you place your fingers of the right hand going from north to south to the left of the page, and if you now turn your right hand so that your thumb is pointing up the page, will someone tell me what direction will your palm move to give it a slap? Will it be out of the page or into the page?
Out of the page.
Good, out of the page. Okay, so that, yeah, so that will be out of the page. Now there are 2-3 other one, and that you can do it in your own time. Now, so that was all Friday's lesson, but because it is the basis of today's lesson, so I thought we will have a look at that one. So now let's look at this today's lesson. Now here, instead of a single wire, we have a loop of wire which is placed in a magnetic field. And that's how whenever there is a current carrying wire or a loop of wire is placed in a magnetic field, it will experience a force, therefore it will move, and that's how the motors are constructed. So let's look at a little bit detail about this diagram. So magnetic field is going from north to south and to the right of the page. This is the coil A, B, C, D. And as you can see, the current is going from D to C, C to B, B to A, and back to the battery, wherever the current was coming from. Now, if you now use your right hand slap rule to find the direction of the force, so place your thumb in this direction, and your fingers should be to the right of the page. And if you do that, your palm moves down the page. So that's the direction of the force on this one, this part of the coil. On this part, if you apply the same rule over here, then force is upwards. Now, this is the axis which is mounted on something, so the coil can rotate about this one. Before we talk about the motion, let's look at BC. So current is going from C to B, or in this path, it is going from A into this direction. So B to C is parallel. So current is going from C to B, which is parallel to the lines of magnetic field. It's in the opposite direction, but nonetheless it's parallel. So the charges in this part will not experience any force, but the charges which are making current, they will experience a force. So this part of the coil will move downwards. This coil will move upward. So as a result, this coil will start rotating in a clockwise direction if we are looking from this side. So that's the direction of the motion. So that's the basic principle. How do we find out the direction of the movement? But there's more to that. When we look at the motor, there are commutators, there are brushes, which are shown in this video over here that you can watch. Now, how much is the magnetic force? You know, in the previous lesson, we said it is proportional. Magnetic force is proportional to magnetic field, current, and length. L is the same thing. Now, in this case, length will be the length, this one, DC or AB, which are placed in the magnetic field. So if we look at one side, then that will be the force on side AB or CD. But because there are two sides, so therefore force will be twice more than that. Remember, there is no force on side BC or AD. So that will be the total force. And if there are, and you know, instead of one loop, there will be many, many loops. So therefore, force will be that many times larger. So again, we're using the same formula that we used in previous lesson, but you will be trying to figure out what is the direction of on this side or that side, or what is the total force if there are 10 loops or if there are 20 loops and so on. So if we come down here, I will just show you this one in a minute. Just bear with me for a minute, girls. Now, do you still see my screen and there is kind of animation?
Yeah.
Yeah, okay. So I will just, so it is the same thing. A coil is placed in a magnetic field and it moves. So magnetic field in this one, so that's the north pole of a magnet, that's the south pole of the magnet, and lines of magnetic field are going downwards. So these two parts are connected to the battery. So current is coming, it goes from here and into this part and comes back. And again, if we apply right-hand rule, we can see. So these black arrows are showing you the direction of the force. Okay. Now, so that's only one coil, and if there are many, many loops, then again the force will be those many times greater. Like, let me see just over here. Okay, so in this position, if we want to figure out what's the direction of the force, what you can do is current is going in this direction. You can place your thumb in that direction, put your fingers in the direction of this magnetic field, which is downwards, and your slap will move in this direction. And here, your slap will be in that direction. That's the direction of the force. And these things over here, there are commutators and brushes, which will make So direction of the current will stay the same even the coil has turned. So you don't need to go in the detail of how this one is actually working. The idea was just to show you that this principle is used uh, to make motors, and that's just a simple kind of a diagram of a motor. And we can change the speed of this one. So in your own time, you can kind of play with that. And if I can come back to the one, so that was the first one. Where is the second one? Okay. Okay. Yep. Okay. So that is mainly today's lesson, and the one that I explained before, that was Friday's lesson. So together, if you could, after, again, it's the same thing. Just it will be good if you could watch this video and you copy your notes. And reason for asking you to copy the notes is that just like when you play piano, your fingers know where to go if you have practiced enough. So it's the same thing. If you have copied these things, so it stays in your brain, but at the same time, little bit memory goes into your fingers when you write it. Okay, so write down all these notes, and then there are some instructions here, what you have to do. So question 1 to 3, magnetic force, that's a page 10. And this one. So let's see if I could go back and let me see if I could figure out how. Okay. All right. Okay. Now I'm back onto the screen. So good to see some others have joined in. Do you hear me, girls?
Yeah.
Yeah. Okay. So any questions, girls? All good?
All good.
Okay. So if all good, then we will just end the meeting now, so you can get onto your lesson. And there is still like about 35-40 minutes left, and then so complete today's work, and then again the lessons for other lessons. There will be 4 lessons this week, and I think I posted some of them. And so good luck, girls, for this week. And just if you've got any questions or query, feel free to email me. And thank you for joining in. So that's all from me, unless you've got any other question.
Thank you.
Okay, thank you, girls.
Thank you.